Hey guys, it's just math, y'all. Welcome to another video. Today we're going to look at some more information that you can get off of a graph of a function. So let's get started. Today we're going to look at more information from graphs, and we're going to look at three basic things. We're going to do the intervals, where the functions increase, decrease, or constant. We're going to use our interval notation, so make sure you are refreshed on your interval notation. We're also going to find the maximum or the minimum of our function. These are sometimes also called relative maximums, relative minimums. And we're also going to determine if a function is even, odd, or neither based on the graph. There is an algebraic technique that I will not go over here, just from the graph. Now, we've already learned domains and range, x and y intercepts, and evaluating from a graph. See the previous video if you need assistance with that. Okay, first example, we have a very interesting looking graph here, and we want to decide if this is going to be increasing, decreasing, or constant. The intervals, that is increasing, decreasing, or constant, and these are intervals of our domain. So if we look left to right, we always read left to right. We have a decrease section, we have a constant section, we have an increase. We have another constant, and we have a decrease section. Okay, so now the increasing section is the section from x is 1 to x4. So that's the interval from 1 to 4. The decreasing section, there's two of them. The first one is from when x is negative infinity and stops when x is negative 4. And then the second one starts when x is 6 and goes to when x is positive infinity. And then the constant, again, there's two sections where this function is constant, and that's from negative 4 to positive 1. These are x values because these are intervals. And then again, from when x is 4 to when x is 6. Now, if you'll notice, I did not even put the y values on here, because when you are doing increasing, decreasing, or constant intervals, these are sub-intervals of your domain, and we only look at the x values. Completely ignore the y values for this one. All right, next up is another one. This one's a little bit easier. It's not as detailed, but it's the increasing. This one is always increasing, and again from the x value. Stop the video and see if you can figure these two out. Okay, here we go. Increasing from x0 to x infinity. It's increasing the whole way. It's never decreasing, and it's never constant. And here's that hint again down here at the bottom. Remember, you read your graphs from left to right, and you must ignore the y values when doing the increasing, decreasing, or constant, because these are open intervals of the domain. These are like sub-intervals of the domain. So we're always looking at the x's. Okay, that's interesting. Let's try something else. How about the minimum and maximum values here? The minimum and maximum values. Okay, and so this time we will be looking at both the x's and the y's. So let's look at this one. This particular function has a minimum value of -3. The minimum value is -3. Now, what is the x where that minimum value actually occurs? The x number where that occurs would be at 0, because that's the x number where that minimum occurs. And it has a maximum value. It actually has two maximum values. And the maximum value of the function is 5. That is the highest number that we have on the function here. The maximum value of the function is 5, but there are two places in this function where this maximum occurs. This maximum occurs when x is -4, and it also occurs when x is +4. These are sometimes called relative mins or relative maximums. That term relative because sometimes we have arrows on our functions, And when you have arrows on your functions, there may be absolute maxes or min. So, all right, let's look at something different. Even, odd, or neither. Even, odd, or neither. We can classify a function based on whether it's even, odd, or neither just from the symmetry of the graph. Now, symmetry is kind of like a mirror or a rotation. And so if it's an even function, if the graph is symmetric to the y-axis. And so there are 3 examples there that the y-axis acts like a mirror. So yes, this is an even function. This one's also even. And this one is also even. I don't know why it's doing that. Okay, and so now an odd function is symmetric to the origin. And now this one's a little tricky. It says rotate 180 degrees, or also just turn it upside down. If you turn this function upside down and it looks exactly the same and it's in the exact same location and it lands on itself, then this is symmetric to the origin and it's considered an odd function. Okay, so these both here are odd functions. And then we have neither. If it's not either, if it's not even and it's not odd, then it's neither. And so here's an example over here in the bottom. This is neither odd nor even. It does not have the y-axis symmetry. I cannot fold it over the y-axis, or the y-axis is acting like a mirror. If I rotate it 180 degrees, it does look similar, but it's not in the exact same location as it was. It's not in the exact same location. I can't spin it on the origin. Think about the fact, can I spin it 180 degrees around that point? And no, I can't. Because if I did that, if I spun it at 180 degrees about the middle of that, it would not still be the same picture. And so that's why it's neither. Okay, this next example up here is going to have everything we've done with the pictures of the graph, which would include this video and the last series of videos. Okay, so let's look through this one. We're going to go through it kind of slow, maybe too slow, but hey, we'll try it. Maybe not. Okay, so now the domain. We've talked about this before. This is left to right using our interval notation. The far left of this graph, I have an arrow. So that's negative infinity. And the far right of this graph, I also has an arrow. That's positive infinity. The range is bottom to top. The very bottom of this graph is a point, -4, and the very top of this graph back over here would be this arrow here. That would represent the very top because it keeps going up. So that's positive infinity. Now the x-intercept is also called a 0. This vocab showed up in the homework. I don't know why. It shouldn't be there, but I'm introducing it. The x-intercepts for this particular graph are here and here. And that's -5. That's the one on the left. Let me erase that. On the left, we have -5, and on the right, we have -1. So we have 2 x-intercepts, the one on the left and the one on the right. And then the y-intercept, we only have one y-intercept. It's way up here, and that's 5. And then increasing, decreasing, and constant. Okay, this is a little interesting. Again, we're going to ignore the y's here. Don't forget to ignore the y values. We're going to ignore the y values. It is increasing on this section right here. It's increasing right there. And the x values for that, the x values are -3 all the way up to 0. The x values for that would be -3 to 0. Decreasing is here. And again, we look at the x value. The x value for that would be negative infinity. And the x value for that stopping point would be -3. And then the constant would be 0, that's the x value, to positive infinity. All right, that can be tricky when your function is all out of whack. It would make more sense to me if I would write them in the order that they actually occur, but we don't ask that. If I would say just in general, where is it increasing, decreasing, and constant, I would say my answer would look like this. Decreasing from negative infinity to negative 3, increasing from negative 3 to 0, constant from 0 to positive infinity. I would have them in that order because that's the order that it actually occurs. It decreases and then increases and then constant. But I'm sorry, the order, I can't change the order there. But that's what makes more sense. Okay. Number H, letter H, number at which there is a relative minimum. The number at which the relative minimum occurs. This is our X number. The relative minimum, the only minimum we have, is at negative 3. That's the X number where it occurs. And then what is that value? That value, the relative minimum of the whole function, is negative 4. That's the Y value. This is the X value. This is the Y value. And then this J, this is a really interesting question. It says the values of X for which the function is negative 3. Where is the function negative 3? Here's negative 3 for the function. This is like your Y. Y is negative 3. And the X values for that, the one on the left is negative 4. And then the one on the right is negative 2. So we have two values of X. Again, values of X. These are X numbers where the function is negative 3. All right, K. Two more. We're almost done. This is the last one. What is the value of the function? F of 4. This means this is the X number. Can you tell me what the Y number is? So when I find 4 on the X axis, which is right here, the Y value is 5. So the answer for that one is 5. Last question. Even, odd, or neither. This is neither. There is no symmetry to this graph. This is neither. All right, this is a doozy of a problem, but you know what? It's just math, y'all. You can do this. You can do this. See you on the next video.